Before we move on to alcohols this week, I just wanted to take a minute to go over that bonus question. So, well, I'll leave it up here. The question was regarding this molecule, number 13, which looks like okay. And first we were asked to mark the asymmetric carbon atom, the asymmetric or chiral carbon atom, which is this one right here, right? What does that mean, chiral or asymmetric carbon? What's the definition? What's necessary for that carbon to be? Right. To be an asymmetric or chiral carbon, it has to have 4 distinctly different substituents coming off of it. If any 2 are the same, it's impossible to be chiral, okay? So obviously if you look at this carbon here, you've got this group which comes off eventually to a point of difference here at the double bond. This group here doesn't have that. Then you've got this propenyl group here, and then the thing that's not shown is this hydrogen back here, okay? Would be behind the plane. So then we're asked to draw the form of this, the D form of this molecule. Well, the D form would basically be the same. Well, we would just basically flip this over and make this group go back and this group go forward. Well, actually, no, we wouldn't. We'd have to flip the whole. Then this bond comes around here. So, oh, that would be the same molecule if you did that. Sorry, you're right. Yeah, that stays where it's at. All you would do would be take this, and that goes back. So the D form would be. You're not even a chemist. He's not a chemist, but he understands symmetry, so that's good. So then this is, you got your H here now. So the H is now coming out. So this is L, and the molecule was L-limonene in 13. So the mirror image of that would be D, this is D-limonene. Move this all the way. Now, we're going to talk more about this in this section when we get to diversity of nature, but the D-limonene is actually the more common one that predominates the citrus oils, okay? That's the most common. If I was going to be specifically, when you are asked the question about the most common molecule in all of essential oil chemistry was limonene, but specifically it would have been D-limonene. I'm not going to count it wrong if you didn't put D-limonene, but this is what's in citrus. Then we ask, is the asymmetric center in the R or S configuration in the D form? So we're going to look at this one. And the easiest way to approach this, if you remember when you're trying to figure out RRS, you have to put these things in imagine it in a situation like this, where the hydrogen is going back. If you can get it in that, orientation, and then you assign numbers to the priority, to the different priorities to the different groups. Biggest being number 1, and down the line like that. So the way I did this was I look at this one, since it's already got the hydrogen going back, and then you would assign the priorities. Well, this would be number 1 because you're going from a carbon to a carbon immediately to a double bond. Then this group here would be number 2 because you're going from carbon to then a double bond here. This would be 3 because you're going carbon, carbon, and then just another carbon. So this is how you would assign that priority. And then is this going clockwise or counterclockwise in the 1, 2, 3? You go counterclockwise, right? So this configuration would be S. S is counterclockwise. So this one must be the R. You could go through the same reasoning if you wanted to work with this one first and just flip it around and then do the same thing. But since this was already in the configuration I needed in, I worked from this one. Okay. So this carbon would be the R configuration, and it's the D-limonene is in the R. And then I ask you, what do D and L stand for? D is dextrorotatory. And L is levorotatory. And what do they tell you about the molecule? That tells you what? Right, the direction that they rotate plane polarized light. So D, dextro, is right, L, levo, is left. That was it. Basic sophomore organic chemistry. Who got that right? Good job.
I think I read C wrong. I got A right because I thought it was talking about the original.
Okay. Just a little fun. It's not going to count for a lot, but just thought I'd keep you on your toes. That's on a bonus question. That'll typically be something that you're going to have to do some figuring. It's not going to be anything that you could have memorized. Okay. This week, we're going to start the section on, well, we're going to start and finish the section on alcohols. And alcohols are a very important group in essential oil chemistry. Now we're done with, well, we've talked about the hydrocarbons, so now we're going to introduce oxygen into these systems. And the first group that we talked, the simplest oxygenated molecules in these types of environments are the alcohols. So this is group 2 in our outline. Okay. And some properties of alcohols are, first of all, we know from organic chemistry they are defined by what functional group? OH, hydroxyl, whatever you want to call that. But the way we represent that would be basically ROH. Okay? Again, where R stands for any large carbon-based group. If you see an OH, you know that the molecule is an alcohol, or at least has an alcohol moiety. It could have other things on it too, other functional groups, but at least it has an alcohol portion to it. If that's the only other non-carbon or hydrogen group, then it is definitely an alcohol. And nothing else. Okay. Another thing that we always note about the alcohols is their names, and this is something that goes across the board even into essential oil chemistry. I'm not going to ask you formal IUPAC names on these, but you should know that their names always end in OL. And that is pronounced all, not ol. And its pronunciation to people that haven't had organic chemistry, it's important because when you get to the aldehydes, they end in AL, and their tendency is, if you have not had organic chemistries, they refer to that as an all. They will pronounce the AL sound as all, but it should be pronounced al for an aldehyde. So phonetically, that is pronounced all. So for example, ethanol. We're all familiar with ethanol, right? Some of us more than others. Okay. The simplest alcohol would be what? Methanol, right. Meth meaning one carbon bonded to the OH group. And then, since we're showing one bond to the OH, the other three bonds have to be hydrogen. So that's usually written CH3OH. By the way, when we're writing out the formulas in organic chemistry for these, we typically would denote the H that's on the O as separate. I mean, you could theoretically write a chemical formula for this as CH4O, but we don't do that because we want to emphasize the fact that this is an alcohol, so we prefer to write it like this. And this is called methanol, which is wood alcohol. Okay. We don't see it in essential oils, but it is a natural product. Other familiar alcohols, which most people know, are again ethanol. We've said that, which is the 2-carbon alcohol. Right, 1, 2, and then the OH group. I'm not going to put the hydrogen on there. And then there's propanol. Sorry, we don't use that. We use isopropanol or isopropyl alcohol, which everyone has used. It's probably in everybody's medicine cabinet, which would be, now propanol, just normal, we call N-propanol, normal propanol, would be just the 1, 2, 3 carbons and then the OH. It's a straight chain alcohol. Isopropyl means that we take the center carbon and we put the OH group on that. You could also call this 2-propanol, where the 2 denotes the location of the hydroxyl. Again, this is not in essential oils, but just for some refresher course on how we name organic molecules, and just want to touch on that a little bit. And some the odor properties of alcohols and essential oils. And I'm talking here about just simple alcohols, or of simple or unsaturated alcohols are somewhat, well, they're fairly strong on these small chain alcohols. We're talking about things that are less than 12. Strong, fatty, somewhat fruity. Fairly harsh. While they are common, like, let me give you two examples of some normal or simple alcohols that are found usually in citrus oils in small quantities, are things like 1, 2, 3. Like this one, and this one. How would we name this one? Pardon? Octanol. More specifically, 1-octanol. Right? Because we could put that OH group here, here, and you can. That's true. If there is no number, you have to assume it's just one. But to be complete, you would call that 1-octanol, according to IUPAC. And this one would be 1 what? Pardon? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, sorry, I meant to draw. I didn't mean to draw that. I meant to draw this one. 10 carbons, which is what? Decanol. If you, I don't have any pure samples of these here, but if you had it, you would notice that you could, see how this would be a slight character of orange in the orange, if you smelled the orange oil. These are both in orange oil. It's very small amounts, less than 1%, but they're there. Typically less. Could be more. Could be around 1%, but typically less. Just know that they're minor components of citrus. And we refer to these things in the industry. Octanol, decanol is fine, but a lot of times they'll call this alcohol C8 or alcohol C10. You'll see that kind of thing a lot. They'll do the same thing with aldehydes, aldehyde C8, aldehyde C10. They don't do it with ketones, but they do it with alcohols and aldehydes. Okay, so while common in citrus in small quantities, normal unsaturated alcohols are not typically present in large quantities within any oil. It's not very common that you would see 15, 20, 30% of one of these types of alcohols in an essential oil. They're typically very minor components. Okay. So that would be just a definition of a general alcohol, and if you wanted to, I don't want to call, we could call those saturated alcohols. If you wanted to make us that first, a letter A, a subclass of alcohols would be the saturated alcohols. Which would be things like C8, alcohol C8, alcohol C10. Okay. So not a whole lot of time to spend on those. But the next class is one of the most important classes in all of essential oils, and that is the monoterpenols. All right. Now these tend to be better smelling. Than the saturated alcohols. More floral in nature. In character, I should say. Yeah, they're older. Therapeutically, they're generally considered to be relaxing. And antiseptic. But big word association here with the relaxing aspect, or the soothing, relaxing kind of aspect that they're attributed to have in a lot of different oils and aromatherapy and things like that. Now, how do we get these things? Well, they're formed basically by the reaction of water with some monoterpene. Okay, so for example, let's take the most common of all the monoterpene alcohols, which would be this molecule here. This is called linalool. Linalool. It's pronounced linalool, or even linalool. You'll hear pronounced either ways except linalool. That's actually more common than linalool. Linalool. Now we could imagine a reaction from, say, this thing here. Oh. This is known as myrcene. This is a monoterpene you haven't seen or smelled. It's a common one, very reactive one. This stuff, if you leave it in a bottle for, say, 6 months to a year, you'll come back and the stuff will be a rubbery, solid mass as it reacts with itself, polymerizes. But, so if we imagine under acid catalysis, a reaction with H2O, we are adding water across this double bond. So the hydrogen's going to go to this carbon, and the OH goes over here, and we end up with linalool. That's one way. Another way would be to start with either cis or transosamine, which are or okay. Which one of those is cis and which is trans? Yes. Top one is cis. Anyway, if you imagine, again, you're going to add water across this bond, in this case. And the same thing here. You're going to, and either way, you're going to end up with this, with the reaction with water. Because remember, you have, once water adds across this, and the... No. Not resonance, but there's free, remember once the water's added across here, it's a single bond now, and there's free rotation around the single bond. So even though this group is shown up here, and that one's shown down there, this is constantly rotating. So once this is added here, and your OH is added, your oxygen, your OH group's here, then this can, or sorry, here, and then this can rotate around to that orientation over there. It's not fixed anymore. This one's already in the same configuration as what that looks like. So you add your OH here, your H here, and then boom, you can see how it's gets you right there. This one, once you add it, then you have to imagine a rotation around a single bond to get to that. These are common monoterpenes found in lavender and other things, but they're known for being in lavender at anywhere from, say, 5 to 10%. They're decent smelling, but you would know that by smelling them, once you had enough experience, that all these terpenes have that same kind of feel to them, that sort of, just that, I don't know how to describe it other than that hydrocarbon-y feel, the sort of that gasoline-y feel, but it's not like, doesn't smell like gasoline, but you know what I'm saying? It's that, whereas when you smell the alcohol or the alcohol version of these monoterpenes, they are completely different in character. They're more rounded, smoother, less harsh, more pleasant. So, and it's, pardon? Oh, I missed double bond, sorry. So, we know, what's the formula for a monoterpene, always? No. C10H16, monoterpenes. Your aromatic hydrocarbon was a 14 carbon. The phecyamines. So C10H16, which means they have a molecular weight of 136, right? Because we have 12 times 10, 12 for carbon, times 10 is 120, plus 16 is 136. So if we add water to that, what is the formula for a monoterpenol always going to be?
C10H15.
C10H. Yeah. Well, we're at, no, it's 18. C10H18O, or, right, because we're adding two H's. we're adding H2O, right? C10H18O, or if you want to put C10H17OH. But if you just wanted to put the most concise formula, you could write it like that. Which means they have a molecular weight of well, it's just 136 plus water's 18, right? It's 154.
60.
Oh, no, water's 18. 16 plus 2. 16 for oxygen, 2. Yeah. So 154. Always for monoterpenol. So let's smell your linalool there. And linalool, like I said, is the most common alcohol. Red flag. And it's found in a lot of different things. It is the characteristic odor of both coriander and rosewood is another one that it would be. Rosewood and could be up to 90% in rosewood, but it's a very high percentage in coriander. Could be 80%, let's say. And you have your sample of coriander there to smell it against. Now, the thing about this is really, the coriander you have is a really good coriander. You can get coriander that smells a lot more like linalool than this one. The reason this one is good, you can smell those other notes in there are these aldehydes, and we're going to cover aldehydes next, but the linalool is the main component, but then you have all these little powerful aldehydes in there that give it another character. But hopefully you can still get the character of the linalool. Coriander is, have you ever used coriander in seasoning before? And spices and cooking and things like that? It's a little round ball-like seed. It is the seed, the oil that you use the seed to make the coriander oil, but if you distill the oil from the leaf, it's cilantro, the same plant. Everybody knows cilantro. It's Coriandrum sativum is the Latin name. And so you could get even a little bit of cilantro character out of this. Now, if you smelled cilantro oil, it would blow you away. It would be so powerful. I mean, if you got a drop on, you'd be hanging with you all day long because it has a high concentration of the aldehydes. Still some linalool, but a lot higher concentration aldehydes. Thoughts about linalool or coriander? The linalool smelled like mint to you? Well, wait till we get to mint. Hopefully you didn't fill the wrong bottle. Oh, you got that. Okay, you got the kit, that's right. It should have a floral character to it, the linalool. It's in a lot of things. It's in lavender. Lavender at about 40% or so, 30 to 40% usually.
Coriander's got a little fruity.
Coriander has some fruity, and that's from those aldehydes and other smaller components that are in there. All right. So probably, pardon? What? No. Coriander is an essential oil. Linalool is the main component of coriander. All right? Essential oils are a collection of hundreds of molecules sometimes. And this is just the main component of that. And linalool is not a terpene. It's not a monoterpene. It's a monoterpenol, right? Monoterpenol. So that's what we're talking about right here.
What did you say the linalool hits to when you smell it?
What does the linalool hit to? Straight linalool, floral. It probably most resembles rosewood. Most people probably never smelled true rosewood because it's endangered species now down in Amazon. But it would have that character to it. You would definitely, if you smelled rosewood, you would definitely say, yeah, linalool.
You said it's 90 or
It could be up to 90%, yeah. But again, it's a very common one. It's in lavender, it's in coriander, it's in cilantro, it's in bergamot, which is a citrus. You could go on and on. There's hundreds of essential oils that contain linalool. Anything else? Okay. Now the second most common monoterpenol that I want to talk about is one called geraniol. Take a guess at what essential oil geraniol's in. No, it's actually patchouli. So, and I don't want to get this wrong. Geraniol is this one. Yeah. You'll notice when we draw a lot of these structures, there's usually at least one point in there, and I should have pointed it out on linalool, one chiral center on these things, which really is what attributes to the complexity of these things. Did I draw that right? Yeah, according to this I did. All right. Well, linalool, I didn't point it out, but there, if you look at linalool, the structure there on your sheet, the carbon that has the OH group is your asymmetric center. Okay, now let's smell geraniol. Anybody ever smelled geranium oil before? It's in rose. It is in rose. So that's a good recognition to that. And we're going to smell rose here in a minute. But it is the main component of palmarosa oil. Geraniol is, yeah. It could be up to 90% in palmarosa. Mm-hmm. Palmarosa is it's a grass. Not anything related to rose, but I would make a joke there, but it would be inappropriate. Palmarosa. It's also obviously in geranium. That's where it's got its name. Usually in geranium, depending on the origin, geranium, you have several origins. You've got Chinese geranium, you've got Egyptian geranium, Moroccan geranium, depending on where, and Madagascar geranium as well. So depending on where it comes from, it can range anywhere from 20 to 45% geraniol, I would say, depending on the origin. So again, you should notice that this is floral in character, right? That should be really the first thing that hits you. That would be your descriptor for this. First thing, floral, when you smell this. Yes, so, right, there's no point on that structure where you see a carbon atom that has four different substituents, right? All right. Now, another important one, which you don't have a sample of, is one called citronellol. And you can look up the structure. I don't need to write it, but since we don't have it. Citronellol does have a chiral center, and so it does affect the odor, if you have the L form or the D form of citronellol. And citronellol is the main component of rose oil. Citronellol, I would say that's probably your geraniol and citronellol, or I don't know which would be more prevalent. They're real close there together. I'd have to give the edge to geraniol and then citronellol. But now, from its name, where would you guess that came from?
Citronella.
Citronella, right. Yeah. Huh? Well, have you ever, you know what citronella is? Okay. Citronella is a grass. A lot of people use it. You've probably smelled it before in like these tiki torch lamp tiki torch lamp fuel that you light, and and you think candles. It repels bugs, supposedly. It doesn't really work, but people think it does. So yeah, citronellol, another important one. And it's in main component. Actually, this can be the main component of geranium. Let's just say major, but it could be the main component of geranium when geranium, usually these will flip-flop depending on the origin. In some origins, citronellol is the highest, and in other origins, geraniol is the highest. But so it's a major component of geranium and rose oil. Now, I don't have geranium, but I do have a sample of the finest Bulgarian rose here, so you're in for a treat. And this oil is over $8,000 a kilo in bulk now. Oh, you have geranium?
Yeah.
Oh, let's smell geranium. Sorry, I forgot you had that one.
I was wondering, because it ends in that, you spelled O, this one ends in A-O?
No, it's geranium. Now this is the whole oil. Now this is, I think, a Chinese geranium is what they filled these with. Oh, we have citronellol too? I need a list. Can I have?
We don't. You have.
Oh, I have your list? I have your list? Well, where'd it go? Does that hurt? No, you need that. Is that an extra? No, you keep it. You keep it. I want you to have it while we're in class. Sherry, you had your thing up here today, right? All right. Well, my computer keeps shutting down on me. Okay. So, Yeah, we have, no, oh, you do. No, you don't. You have citronellal. You don't have citronellol.
It's mislabeled because it says citronellol.
Let me see that. That somebody mislabeled that. They did. Yeah.
Well,
You got the prototype kit.
so this is really out.
Let me smell it. I'm not sure. We'll see if it's misfilled or mislabeled. Just.
That's what I think it's a little bit relabel it or replace it.
I need a strip. Can't smell it out of that little hole. I'm guessing that's. No. No, it's citronellol. They did give you citronellol. Somebody mislabeled it.
We have stuff that you want to smell it.
I mean, they gave you the wrong stuff. They labeled it correctly, but they gave you the wrong stuff.
How about that one?
That's AL. That is citronellal, which is an aldehyde, which is a different group. Yeah, that's definitely citronellal. All right. No, we got that straightened out. So no, you do not have citronellol in your kits, but it is a very important one in essential oils. You should definitely notice the floral character on the citronellol, but you don't have it. But if you want to smell it, just ask Dave or pass it around if you want. Anyway, I wanted to show you Bulgarian rose oil, which has citronellol as its major component, and let you compare that. Now just pass this bottle around, because just to put it on a strip is a waste. I'd be out of it by the time. It's pretty powerful. You can smell it. Now, if I had a rose fragrance, I think I touched on this in the first day. If I let you smell that side by side, $8,000 a kilo oil, and I let you smell that side by side with a $8 rose fragrance, most of you would probably like the rose fragrance better, because that's the way our society's been conditioned. But once you get an appreciation for these things, and if you put that on a strip and you really delved into it, you'd see the complexity of that is pretty amazing. There's probably over 300 components in that rose oil. A lot of little minor tiny things. But the main reason I brought that in is, one, to let you smell it, a complete oil. It's a fine oil that would have a monoterpenol, but also to let you smell the difference between a plant that was steam distilled in that case and one that is solvent extracted. This is a solvent extracted rose absolute, okay? That first with hexane, hexane's evaporated, we get the concrete, extract the concrete with ethanol, evaporate the ethanol, and then we're left with the absolute. Notice the color. Okay, the rose oil would be almost colorless. Here, Dave. But this, has color in it from the plant material, and this stuff is completely different. This would be more of what you probably picture in terms of a rose fragrance. The main difference is rose oil, we're talking Bulgarian here. It's a little different for Turkish. But for Bulgarian, rose oil, main component is citronellol. For rose absolute, it's phenyl ethyl alcohol. It's also called rose alcohol or PEA. And so it is that one, I believe. Yeah. methyl alcohol, PEA. That's a trivial name for it. So I'm going to pass this around. Just pull the little stem out. I'll leave it loosely on there so you have to. But you're going to see how different that is than the rose oil that you just smelled.
This is Rose Absolute.
This is Rose Absolute. Now notice, and I did this on the test, I wrote your paracymene. I didn't use the circle. I used the other notation for the phenyl ring, right? Equivalent acceptable structures, but just kind of a little mix it up there. But I generally will write them with this notation because it's a more accurate picture of what's really going on. If you fix those double bonds, it makes it look like those double bonds are localized, and they're not. You see the difference in those? It's huge. Like the Absolute better? Yeah. That's, I would say, most people's, when they first smell these things, they probably like the Absolute better, but over time they tend to change. The Absolute is also very expensive. It's probably more like, depending on the market, $2,000 to $3,000 a kilo. Well, it's real easy and tempting for a lot of producers to slip in a little PEA, especially since this is dirt cheap. This is one of the cheapest aroma chemicals out there. It's probably like $5 or $6 a kilo. Easy to make, and really it's used in so much in the fragrance industry. It's produced in hundreds and thousands of tons a year. Every rose fragrance on earth has this in it. Every old lady perfume has that in it too. Okay. So we went to monoterpenols was B. Now we are going to go wow, is it really 8:30? We're going to go to sesquiterpenols. Okay. Sesquiterpenol properties are, obviously they're bigger molecules. They're going to be less volatile than the corresponding monoterpenes. Tend to be thicker in consistency, less reactive, milder smelling, typically more woody. I wish that we had an example of and I almost included one. Cedral would have been a great example to include here, but you got to make choices and you just can't cover everything. So you can imagine, and well, they're considered therapeutically to be generally anti-inflammatory. But if you smelled, for example, pure Cedral, it would immediately spark your mind thinking about cedar wood. And just as monoterpenols came from the addition of water to a monoterpene, where do you think sesquiterpenols come from? The addition of water to some sesquiterpene precursor. So, for example, we could talk about the water addition to cedrine, which is this. Well, I don't need to put those structures. We're not going to talk stereochemistry here. Okay. This is cedrine. H2O with a little acid catalyst, let's say. And we're going to add across that double bond to get. Now, here's a good chemistry question for you. Just what you know about basic organic chemistry. If we were going to do an acid catalyzed hydrolysis of that double bond, which carbon atom do you think the OH group is going to end up on? Yeah. Yeah, that's right. The one with the methyl group. Because you're going to form a more substituted carbocation there, right? So we're going to get that. That is cedrol. What? Again, that would smell. Both of these would remind you of cedar wood. This would be the finer odor of the two. It's a very useful aroma chemical. It actually is produced from the cedar wood oil. You can actually crystallize this out of cedar wood oil. It'll just fall out if you cool it down low enough. In fact, crystallization can be a problem during the distillation process. Sometimes as it's coming over and being cooled in the condenser and things like that. If it gets too concentrated, it just starts falling out. A lot of cedar wood oil produced here in the United States, down in Texas. Some other common sesquiterpene alcohols that are noteworthy are things like patchouli alcohol, which, wonder where that comes from. Anybody smelled patchouli before? Nobody? Well, besides those of you who are. Yeah, patchouli, as you may have heard of it. It's a commonly used hippie oil. Back in the 60s, they used to use it to cover up the smell of marijuana. It's a real powerful smelling oil. It's a nice smell. I like it a lot. Most people, when they smell the pure stuff, the real stuff, the first time, they don't tend to really like it that much. But it is it will cover it up pretty nicely. Not that I've ever tried, but it's got a very distinct odor to it. Very useful in perfumery. Probably in every women's fragrance out there, pretty much patchouli. It It's very common. Other important ones are xanthalol, which comes from, guess where? Sandalwood, yeah. Main component of sandalwood, xanthalol. And carotol, guess where that comes from? Not from carrots. You don't distill carrots. But you can get oil from the carrot seed. That's where it comes from, carrot seed oil. Main component of carrot seed oil. And vetiver is another one. That's, vetiver? Vetiver, which comes from vetiver. Vetiver is another one of these grasses that is used. It's a very important oil for perfumery. It's a very earthy smelling oil. Most of it comes from Haiti and Indonesia. Some from China. A little bit down in South America as well, but very important oil. So a lot of these sesquiterpenes are named like that from the oil from which they're made. But
Did you say the cedrol is the most common?
of the sesquiterpene alcohols, wow, that's a good question. I would have to say because of the sheer quantity of cedarwood oil that's produced in the world, that it would, well, no, actually, no. I'm going to take that back. I would say it's probably patchouli alcohol. But I don't have any samples of pure patchouli alcohol. I could probably get some, but it's pretty expensive. Okay. So did we, we didn't, we forgot to say something about, back in the monoterpenols, we didn't say anything about menthol. But, don't worry. I've got better organized notes that you'll be getting on the web. Is everybody here a member of the group on Facebook? Is there anybody not a member of the Facebook? You should join the group. Because it will, you basically can download everything I'm doing up here. It will help you out. And it'll be in more legible form. Plus, it's a good format to ask questions and so forth. The reason menthol is important, well, let's get out the menthol. I'm not going to draw it because you have the structure there written on your little sheet. And you should notice, like if you had this big container here and you put it up to your face, you would not only smell it and feel it in your nose, you'd feel it in your eyes. And maybe you can a little bit with your small sample, I don't know. But it's I'll pass this around so you can really get a better feel for it. Yeah, it's the main component of peppermint. And so see, when you smell that, compare it to your peppermint sample, and you'll see, yeah, you can smell that in your peppermint, but that peppermint's going to be way more complex.
This is 50-50 menthol.
We got a menthol.
Oh, thank you.
Menthol.
Yeah, your sample is diluted, yeah. So can you smell that menthol in the peppermint? Now I want to say something about peppermint because your peppermint that you have, and this is important, your peppermint oil is redistilled, what we call redistilled. Basically, when you see peppermint, like if you were going to buy peppermint in the industry, you would see it quoted as either peppermint natural or peppermint redistilled. I'll just say Okay. Now, does peppermint redistilled mean it's not natural peppermint? No. What this means is the peppermint natural is the oil that comes straight off the still and no further processing. Now, some people want that, but the thing about natural peppermint is that there are these small components that are sulfurous and some small aldehydes, such as valeraldehyde, isovaleraldehyde, which if you've ever smelled one of those, they smell horrible. They're actually nauseating. In fact, isovaleraldehyde has been found to be actually in vomit. It's like a characteristic aroma of vomit. It's a small percent. All it needs is a small percentage. And interestingly enough, it's also the characteristic odor and flavor of blue cheese. So think about that the next time you're eating blue cheese dressing. Or the next time you vomit, yeah. You'll never want blue cheese again. So let's just get some strips going here. And you have, because I want you to smell these side by side on the strip. The natural versus the redistilled is.
Redistilled has better shelf
Yeah.
life.
Can you get these going? When you smell these, what you'll notice is the redistilled, to most people, is going to smell quite a bit better. And that's because those, when they redistill it, they'll either redistill the oil. Now this is very important. They redistill the oil, okay? The oil's been produced once. They take that oil and they redistill it or vacuum. Fractionally distill. Yeah, your kit is the redistilled. And they'll do that to remove these, because these components are in what's called the heads of the first stuff to come off. Okay, they're light components. They're the first to come off under vacuum distillation. They'll get rid of these, and when they do that, it gives a better, cleaner, fresher, sweeter oil. Did you notice the difference? The natural peppermint's going to have sort of an herbal, weedy smell to it compared to the redistilled oil. Now, some people, the purists, say, "Oh, it's not natural. It's been messed with." But it's no less natural than this. I mean, let's face it. No plant ever distilled itself. It took a man to get that oil out of the plant. Okay? So it's just another extra step after the process to get rid of some nauseating components. But you just can't talk to people. Some of them, they just don't want to hear that.
On the redistill, they probably get rid of the tails too.
Sometimes that is an issue too. But generally it's those lighter things that they're getting rid of. So what I want to point out is if you ever hear someone talk about, "Oh, our peppermint oil is the best quality because it's only from the first distillation," they completely don't know what they're talking about. Every peppermint's from the first distillation of the plant material. They'll say if it's from the second or third distillation, they'll take that same plant material and they'll distill it again, and the oil they get off the second time is not as good. And if you just think about that, why would you ever shut down your still, which is a lot of energy and money involved in getting that thing up to boiling and getting that thing going? You only distill peppermint for 2 hours and it's done. You're not going to get any more oil out of it. The farmer's not going to think, I've collected all this oil, I'm not seeing more oil grow, I'm shutting it down, and now I'm going to tomorrow I'm going to think, maybe if I distill that stuff again, I'll get some more oil out of it today. No, it doesn't work like that. So if you ever hear anybody say anything like that, it's from the first distillation, and it's inferior if it's from the second or third. There is no second or third distillation of that plant material. What they've confused is, there's so much confusion in this industry. They hear one thing and somebody will latch onto it and then they'll totally misinterpret it. They're confused about the redistillation process of the oil, and somehow it got jumbled up in the process and turned into, they redistill the spent plant material and they get an inferior oil. No, that doesn't happen. In fact, if you go, has anybody following the Essential Oil University Facebook page? I'm doing a series right now on myth busting, the 10 top 10 myths about essential oils, and I'm counting them down from 10 all the way to 1 over a 10-day period. And today was number 8, and this was this thing about first distillation, second distillation, third. That was the myth that we busted today. And it just crushes a lot of people's worlds when they hear some of these things, and because they've been told this stuff. But these are things that have to be said so that we can kill the misinformation that's out there. So it'd be good for you to kind of follow that, because there's a lot of people on that group now, or follow that page, and they post to it, and you can really learn a lot about the industry by just picking up on some of these conversations and about some of these oils.
First was cheaper.
Obviously, and that's another myth. They'll think, well, it's a second distillation, it's a cheaper product. But it's not second distillation of the botanical. It's actually more expensive because you got to further process this. This is going to be a more expensive, more desired oil than this. But again, the purist or whatever, they have to market that to the people that want it all natural. But again, no peppermint oil distilled itself. So anyway, any questions about any of that? This product here is what makes it typically into all your gum, your toothpaste, candy, any kind of mint product, mouthwash, whatever, would be this. They're not going to put this in that because it's not going to taste as good. All right. I wouldn't put too big of a crystal in your mouth. A tiny bit wouldn't hurt you, but you will feel it. Oh, great. Yeah, not a good idea to put a big piece of menthol in your mouth. Okay. You'll have good breath for a while, though. This brings us to the final subclass of alcohols tonight, and we'll be finishing up right on time. And that is the phenols. Again, sorry about the digression back to monoterpenols with menthol, but we were in sesquiterpenol, so don't accidentally include menthol with sesquiterpenols. Look at your structure there, and it's clear that it's a monoterpenol. So the phenols. The phenols are defined by an OH group attached to a phenyl ring. Okay? In fact, this molecule is called phenol. Now this molecule is not found in essential oils, but substituted versions of it are. And so the properties are less polar than normal alcohols. than normal and monoterpenols. More prone to oxidation. When they oxidize, they tend to get discolored, and so you'll notice things that are high in phenols over time become darker in color. Phenols, they'll react with iron 3 to form intense red complexes, obviously, because, you know, things that have these aromatic rings can do those kinds of things. Their names, like alcohols, end in OL, so you won't necessarily know by just the name whether it's a phenol or a monoterpenol or a sesquiterpenol. That comes with just experience and memorizing. But sometimes they actually end in the word phenol, and that makes it easier. And like I said, all the phenols in essential oils occur as substituted phenols. So we have things like, well, I want to turn this around. This one, which is thymol, and these are the two major ones. And which one occurs more, I don't know really. They usually occur together. One will just be in a higher percentage than the other. If I was gonna say one over the other, I would probably pick carvacrol because there's more oregano oil produced in the world than thyme oil. And so this is the main component of oregano. So when you smell oregano, you're mainly smelling this. If you were to smell the common thyme, it would be more this. Now, therapeutically, these things are, you know, if normal monoterpenols are antimicrobial, these things are on crack antimicrobial. They're super antimicrobial. Very harsh. Very difficult to grow any kind of microbial in this kind of environment. They're also very irritating, burning to the skin. If you were to get your oregano oil into your cut, a small cut on your hand or something, it would light you up. But there are people that actually take daily doses of oregano oil for their health. Don't ask me how that goes down. I'm not, you know, if it's not done in too large a dose, but you know, that's the thing. Too much of that is not going to be a good thing for you. I wish this is actually a solid. Interestingly, this is a crystal, and this is a liquid at room temperature. Just from the difference in that OH position causes that physical property.
Will Phenols have a very low known?
It's not as low as you might think. Yeah, it's pretty. It's not going to, it's not going to be liquid on a really hot day in the warehouse. It takes a little bit to get it up there. I don't know what it is, but it's a white crystalline material. And this is going to be kind of a sharper, crisper, cleaner odor. Whereas this is definitely, you smell oregano, or you smell carvacrol, and you definitely, first thing you think of is oregano.
When the things are crystalline, are the ones that will dissolve in water, do they smell the same when they dissolve?
They don't, none of these dissolve in water.
Okay, let's say something that dissolves when it's over, do they smell the same when they're dissolved as whenever they're crystalline?
No, you will get some change, but still recognizable. But yeah, you can get some differences. I don't think it's a worry like on the menthol, because when we do the test on the quiz on this section, we're going to have to dissolve that menthol in an odorless base. Otherwise, you're going to know by looking at it that it's menthol. You're still going to be able to know that it's menthol. I don't think it's going to be close to anything else.
The molecule's the same once it comes off in gas, right? You know, the odorless carrier coming off with it.
Yeah, but it's quenched. That's the difference. It's quenched by the solvent that it's in. So you're not going to feel that intense feeling as much as you would of the crystal.
There's a 50-degree difference between them.
50 degrees Celsius?
Carbacol is 1 degree Celsius and Phenols 51 degrees Celsius.
Yeah, that's pretty good. That's a pretty big stretch for just that little change. And you know, this isn't the only example like that. Yeah. Any questions?
I guess it just goes in how well they fit together.
Well, obviously. It's all in the intermolecular forces. Anything else? We're right on time. So next week we're going to hit the, what is it, aldehydes? That's what's up next? Or ketones next week. Okay. See you next week.